As promised, here is a bonus geometry video where we can reconcile our cheat sheets for the circle and cylinders section. So I have literally just copy and pasted each item in the list, and we will go through them one by one. So starting with the area of a circle. So everybody should know this. Area of a circle is just equal to pi r squared, where r is your radius. The circumference of your circle, so that is just the distance around your circle or the perimeter of your circle. That is equal to 2 pi times your radius. But since your radius, 2 times your radius is really just your diameter, you can also think of this as just pi times your diameter. The relationship between central and inscribed angles. So this is our deli ticket diagram. So if we have center of a circle here, our central angle is just made up of 2 radii. So 2 lines that go to the center of your circle, and these form a central angle. We could say that is x degrees. Now every central angle is going to have a corresponding inscribed angle. So your inscribed angle, it intersects your circle at the same points, A and B, we'll say here, but instead of just going to the center, it goes all the way to the end. So what is the relationship between these 2 angles? Your inscribed angle is always going to be half your central angle. Now, how do we use our central and inscribed angles? We use them to find sector areas and arc lengths. And so which angle is the important one? It is the central angle that is going to determine your sector areas and your arc lengths. So a sector area, we have a central angle here, forms this sector here, this pi wedge. So if we want to find the area of this sector, we need our central angle. So we can use our inscribed angle to get our central angle, but then we need to use the central angle that is our proportion. So our sector area here is just going to be some portion of the area of our circle as a whole. And what portion is that? Well, it's going to be our central angle over 360. So our central angle, so our sector area, this is going to be our central angle over 360 times the area of our whole circle, or pi r squared. And then if we want to find an arc length, so say we want to find the length of arc AB, that is just going to be a portion of our circumference. So what portion is it? It's the same portion as over here. It's going to be our central angle over 360, but now times our circumference. So for cylinders, the 2 things we need to know are volume and surface area. So volume is just the space inside. So we can think of this as the space of our pancakes stacked on top of each other. So the space taken up by one of those pancakes is just going to be pi r squared, or the area of a flat circle. To find the volume of our 3D cylinder, we need to multiply that by the number of pancakes we have stacked on top of each other, also known as the height. The volume of a cylinder is just pi r squared times h, where r is the radius, h is the height. Then for surface area of a cylinder, so that is just if we were to flatten out our cylinder into its 2D components and then add up their individual areas. So what is a cylinder made out of? It is made out of our middle tube, which is really just a rectangle of some sort rolled up. Then it's got 2 circular caps on the top and bottom. So our surface area would just be our 2 circles. So the area of our one circle is just pi r squared, so the area of our two circles should be 2 pi r squared. And then we need to find the area of this middle tube, or this middle rectangle, and we said that was 2 pi r h, which is really just length times width, because once you flatten out this tube into a rectangle, this h here is just the width, and this 2 pi r is the circumference, which you can think of as the length around our rectangle. So this 2 pi r h is really just the area of our rectangle, but when rolled up. That is everything you need to know. For circles and cylinders, we will do triangles next.